When we finished the notes the other day, we were talking about mole calculations. And again, remember we need a balanced equation. And this is when we switch from moles of one substance to moles of another. And again, without a balanced equation, you can't do it. But what if we don't have moles? What if we have grams, which is more common because if I tell you to get me a amount of unit, we can measure that on a scale. We don't have mole meters, so really it is much more common to use grams, okay? So here we have what they call a mole mass calculation, okay? What mass of hydrogen, so now we want grams, will produce from 6 moles of aluminum, all right? So if we start with moles, the first thing we have to do is our mole ratio. And then we need to add one more step. We need to change it from moles to grams, which you guys have done a bunch of times before. So it's nothing new. It's just putting the stuff we've done together now and finding our numbers. Okay, so again, don't worry about the solution map. This part, let's just go down here. Okay, write down what we know. We have 6 moles of aluminum. Okay, now we want to get rid of moles of aluminum, so we're going to put that on the bottom, and we want to find hydrogen. Now it says mass, but before we can find mass, we have to find moles. Okay, one step at a time. Okay, so I put moles of aluminum on the bottom and moles of hydrogen on top, and then I look at my balance equation. There's a 3, there's a 2. Okay, that makes sense. Now I got moles of hydrogen, but the question wants to know mass. So I'm going to do one more conversion. I'm going to change moles of hydrogen into grams. Okay, 1 mole on the bottom, and again, I would just use 2. You guys don't have to use 2.016, but if you have to, whatever. Okay, so what I did now is I got rid of moles of hydrogen and I changed it to grams. And this is like we did before when I said, how many grams or what is the mass of 2.4 moles of water? We just switched it by putting moles on the bottom and it's formula mass on top. So you take 6 times 3 times 2 divided by 2. So actually just 6 times 3. So you get what, like 18? 18. Okay? So you can add another step to it. You can, after you get moles, you can change it to grams. And again, this is just a simple thing that we've done before. And again, it's 2 because it's H2. Okay? Not just H. Hydrogen, yes, would be 1, but we have 2 of them. Okay? How many moles of water are produced? Okay, now we're going to start with grams. All right? So before we can use the mole ratio from the balanced equation, we have to change grams to moles. Okay? And again, don't worry about the solution map. We just go down here. All right, so write down what I know. 325 grams of octane. Okay, now I got to change this to moles before I can use my mole ratio for my balanced equation. Just like we did before. Put grams on the bottom and 1 mole on top. So you'll have to find the formula mass of C8H18. So 12 times 8 plus 18 would be 114. And again, you can use 114.2 if you want, or 114. Doesn't matter. Okay, so all I've done here is like we did before. I put grams on the bottom and 1 mole on top. This is what 1 mole, and it's 8 carbon and 18 hydrogen added together. Now I can use my mole ratio because I got moles of this. Notice you do not use the number from the balanced equations here. Whenever you're converting from grams to moles or moles to grams, just use 1 mole. Do not use your balanced equation. The only time you use your balanced equation is when you do your mole ratio. Moles of one substance switch to moles of another. That's the only time. So I put this on the bottom, octane, and I put what I'm trying to find. The question says how many moles of water. So I put a 2 here and 18 here. And if you look, now I'm going to take 325 times 18 divided by 114 divided by 2. Divide everything on the bottom. And you're going to get 25, sorry, you can't see it all, 25.6 moles of water. Okay? Okay, how many grams of silver nitrate are needed to produce? Okay, so we would start with our 0.25 moles of silver sulfide. Then we do our mole ratio, and then we'd switch silver nitrate to grams. So again, here's the answer, but don't worry about the solution maps. This is what I'm worried about. Okay, so write down what you know. 0.25 moles of silver sulfide. Because I start with moles, that's one less step. I don't have to change it to grams, okay? If it's in moles, that's good, you guys. That's one less step you have to do. So put moles of Ag2S on the bottom and moles of what you're trying to find, silver nitrate, on top. Okay, 2, 1. Okay, now the question says how many grams, so I'm going to have to do one more step. So I'm going to put 1 mole of silver nitrate, and I'm going to take 1 silver, 1 nitrogen, and 3 oxygen and add it together. I think it's 170. Oh, sorry, 169.9. I'd go with 170. Anyway, now I got rid of moles of silver nitrate and I have grams, and that's what my question is. So I had to add a step here, okay? So to solve this, I'm going to go 0.25 times 2 times 170. And you get, there's where you get your 85 from, okay? All right, here's another one. How many grams? Now we're going to do mass to mass. And honestly, you guys, this is the most common. Of course, it has to be the longest one. But if you're in a lab and you're trying to do these calculations, this is the one that makes more sense because you're going to weigh out something. You're going to weigh out a reactant, and then you're going to do your experiment, do your reaction, and then you're going to weigh out your product. So that's the only way we can measure things in a lab. So mass to mass makes the most sense. So what happens here is you start with a mass. In this case, we're going to start with, we want to know, we got to produce so much N2O, dinitrogen monoxide, okay? And we need 8.75 grams. So what we need to do is we need to know how many grams of HNO3, this is nitric acid or hydrogen nitrite, whichever you want to call it. We need to know how much of this do we need, okay? So again, it's going to be 3 steps. First, we're going to change grams to moles, and then we're going to do our mole ratio, and then we're going to change it back to grams of HNO3. So we've got to do 3 conversions, okay? Again, don't worry about the solution map. This is what we're worried about. So write down what you know. 8.75 grams of N2O. I know I have that, okay? Now I want to change grams to moles. So 1 mole of N2O, I take 2 nitrogen, 1 oxygen, add them together, and I get 44. That's what it weighs, okay? So now I've gotten rid of grams of N2O, and I have moles. Now I do my mole ratio from my balanced equation. Moles are what I'm trying to get rid of on the bottom. Moles are what I'm trying to find on top. I got nothing here, so that's a 1, and I got a 10 here. So now what I did was I got rid of moles of N2O, and I got moles of HNO3. Again, I'm just converting. My last step, because the question says how many grams, okay, I'm going to put 1 mole of HNO3, and I'm going to take 1 plus 14 plus 48 and add them up together, and I get 63. Again, I don't know if you can see this. I'm sorry. I don't know where to put myself, so I'm not in the way. But I put 1 mole of HNO3 on the bottom and 63 on top. It would look like this, guys. Okay, put that on the bottom. So now I take 8.75 times 10 times 63.02. Again, I just use 63. And I divide by 44. And I get, it's 125 grams of HNO3. Okay, this is the most common. Yeah, it's the longest. Sorry about that. But look at it. You have grams of N2O. So put that on the bottom. This is just what it weighs, 1 mole. This is the conversions we did before. Okay, then 1 mole in the bottom here and 10 moles here. This is my mole ratio. This is the only place you use the balanced equation. And these numbers come from your coefficients. And then last step, we're in moles, so 1 mole, and then find the mass of that and put it on top. Multiply everything on top, divide everything on the bottom. Okay. How many grams of CrCl3 are required? Again, we have a balanced equation. Okay. So we're going to start with our 75 grams of AgCl. We're going to change it to moles. Then we're going to do our mole ratio. And we're going to find moles of CrCl3. And then we're going to change that from moles to grams. Okay. And again, here's what I'm worried about. Don't worry about all this stuff. Worry about this. Okay. So start with what I know, 75 grams. Change it from grams to moles. 1 mole, 143. I guess I'd use 0.5 because remember we always talk about chlorine being 0.5. Okay. All right. So now we got that. All I've done is change gram to moles. I haven't used my balanced equation yet. Now it's time to use my balanced equation. Moles are what I'm trying to get rid of, AgCl3 on the bottom. And moles are what I'm trying to find, chromium carbonate on top. So this is what I'd use. Okay. And again, remember, these are your coefficients. There's, in front of here, we have a 3. In front of here, nothing, so that's a 1. Okay, so now I use my balance equation. I switch from moles of one substance to moles of another. But now I have moles of CrCl3, so my last step is I need to change that to grams. So again, I put 1 mole, 1 mole on the bottom, and I'd use 158.5 on top. Excuse me, ooh, I got a frog in my throat. So And again, I take 75 times 158.5 divided by 143 divided by 3, and I would get 27.6. So that's a mass to mass. And again, I know it's the longest one, but really is the one that's used the most because it makes the most sense. Okay. Here's another mass to mass. How many grams of calcium is needed to produce 48 grams of calcium oxide? Okay. Write down what you know. 48 grams of calcium oxide. Before I can do anything, I have to change this to moles. Put 1 mole here. Some people want to put a 2 up here. Don't do that, you guys. Don't use this equation except for when you do your mole ratios. This is the only time you use it. So these are always 1 mole. So 1 mole here, 56, that's 1 calcium, 1 oxygen weight together. This is the formula mass of calcium oxide. So now I got rid of grams of calcium oxide and I got moles. So now I put moles of what I'm trying to get rid of on the bottom, moles of what I'm trying to find. It says how many grams of calcium. So I put that on top. These are both 2's. Okay. And then my last step, 1 mole calcium. Calcium, since it's an element, I can just look it up in the periodic table, and its mass is 40. So to solve, so I take 48. I don't have to multiply by 2 and divide by 2, you guys. It's the same as 1. So I'm just going to go 48 times 40 divided by 56. And you get 34.3 grams. So what that tells me is if I need to produce 48 grams of calcium oxide, I need to start with at least 34.3 grams of calcium. If I don't have that much, I will not produce my calcium oxide. If that's my job, then I'm probably going to get fired. Because if you're not producing what you're supposed to be producing, they get mad at you. Unless, of course, your dad owns the company, I suppose. But anyway, that's a way of checking to make sure you have enough stuff to produce what you need to make. Okay? And these are just examples again. How many grams of C2H6 are needed? Again, I'm going to start with my 3.7 moles. Okay, this is a mole. This is one less step. Mole to mass and mass to mole are 2 steps. Mole to mole is 1 step and mass to mass is 3. Okay, so write down what I know. Do my mole ratio. Moles are what I'm trying to find here. Moles are what I'm trying to get rid of. Sorry, here, what I'm trying to find up here. The 2 and the 4 come from my balanced equation. And now I want grams of C2H6, so 1 mole. And if you take 2 carbon and 6 hydrogen and add it together, its mass is 30. So 3.7 times 2 times 30 divided by 4. And you get 55.5 grams. That's how many grams I need if I'm going to produce 3.7 moles of carbon dioxide. If I don't have that much, I can't get that much carbon dioxide. Okay, here's another one. These are all examples, you guys. How many grams of K3PO4 are produced? Okay, so we've got our balanced equation. Start with what I know, 1.8 moles. Okay, and again, if it's in moles, you guys don't have to find its mass. 1 mole to 2 moles, because I'm trying to find this. And then 1 mole of K3PO4, I would have to find its mass. 3 potassium, 1 phosphorus, and 4 oxygen. Add them together and you get 212. So again, 1.8 times 2 times 212. I don't have to divide by 1 and divide by 1. I guess you can if you want to, but you're still going to get the same answer. So you get quite a bit. So how many grams of this is produced? Well, if I start with 1.8 moles of this, I'm going to get a lot of this. Okay? If I don't need that much, I can cut this down. But you can calculate exactly what you need. Okay, that's what stoichiometry does. Here's a simple mole to mole, which are the easiest. 1 step. Okay, how many moles of water are produced from 4.98 moles of sodium hydroxide? So write down 4.98 moles of sodium hydroxide, which is this guy. Oh, I didn't even write it out for you. I guess that's one you could try. Okay. And there's another one. I'll leave that for you guys to try. And I think we might be done. Oh, here's a mass to mass. These are just problems for you guys to practice on. Okay. And there's a video there. That's up to you. But the last few, again, I will put this on there and you guys can practice these if you want. Okay. After this, again, the PowerPoint without any narration is on there. You can go back and try these problems if you want. And then there is a video about stoichiometry if you're struggling and you want to review it. Okay. So we are done with Chapter 9 lecture notes.